Okay, so on a radical, the number inside the elbow is called the index, and it's important to pay very close attention to that number. And there are lots and lots of ways to simplify radicals, so I'm going to show you 2 ways. And I'm going to start here actually with number 4. To simplify this radical, what's the index in here? Is it a 1? No, 2. It's actually a 2. That's why it's called a square root. Just like perfect squares have a 2 as the power, it also has a 2 as the index. So it's an implied 2. And that 2 actually tells us how many things we are trying to get, okay? We want 2 of a kind is essentially what we're looking for. This is, I'm going to call it the long way. I'm going to show you the long way to simplify radicals. It works every time. And so to simplify this radical the long way, we're going to expand it, and our job is to find groups of 2. So 121 is what times what? 11 times 11. And then x to the 5th means x times x times x times x times x. Okay. And then y to the 6th means y. Right? Okay. All right. So again, I'm showing you the long way first because I want you to really understand what's happening here. We are looking for the root, okay? When we have an exponent like 7 cubed, when we're taking the cube root, we are looking for the root number, the base, if you will, okay? And so what I'm looking for here is anytime I'm looking for a group of 2, because my index is 2. If I have a pair, if I have a group of 2, I have 2 11s there, one representative escapes the radical. Okay? Now, when I look at the x's, here's a group of 2. What happens when I get a group? One escapes the radical. You love that, right? And then here I have another group of 2 x's, and so what happens? One escapes. What happens to this guy?
He doesn't escape.
He doesn't escape.
No,
he has to stay behind. All right. And so over here, we've got a couple of y's. What happens? One of them escapes. And here we have another pair of y's. What happens? One escapes. And here is a third pair of y's, and one escapes. Okay? And so we have left behind in the radical the lonely x. Okay? And so this cleans up a little bit more. We can tighten it up. It becomes 11 x squared y cubed times the square root of x. And so this is the fully simplified answer. Okay? That's how simplifying radicals works every single time. All right? That index tells you how many we want. So you can always break those down that way. But of course, that does take a long time. So something like this is square root of 252. Again, I need to break that apart. What is 252? I mean, I need some factors. 252. It divides by 9. Awesome. All right. 9 times 28. So there's a 4. It's so 36, it turns out. 252 divided by 36. There we go. So 252 is 36 times 7. What we're trying to find is the largest, in this case, perfect square. The largest square number. So what you could do, because this is a square root, you could say, hey, I'm going to do 252 divided by 36, or sorry, 49. No, 252 divided by 36. Hey, there's a winner, okay? So you can test your perfect squares, and then we're saying, hey, what's the root of 36? 6. If you think about it, that's a 6 times 6. That's a pair of 6s. 1 escapes. And the 7 has to stay behind. Okay? All right. Let's look at number 2. What's the index? It's a cube. So this is a cube root. We're looking for perfect cubes inside 128. Let's see, 128 divided by 64. Hey, that's a winner. So I have -5. I want my cube root. And 128 divided by 64, nicely. 64 times 2. So we're looking for cubes here because the index is a 3. So perfect cube. Does that make sense to you? All right. So what is the cube root of 64?
4.
4. So a 4 escapes. And what happens with our -5 and 4? They multiply. So that becomes -20 times the cube root of 2. Alice, are you paying attention or not? Because you're abandoning me. Are you going to abandon me?
I won't distract William.
All right. This one is quite tricky. Number 5. What's the index? A 3. Can you have a negative inside a cube root? Yes, you can. Yes, you can. All right, so what's going on here? I, again, am looking, because of the index of 3, I am looking for perfect cubes here. And let's see, 162. I have no idea. 162 divided by 27. Hey, there we go. All right. So it turns out, so 162 divides nicely by 27, which could be, I would think, let's see, -27 times 6. That gives you -162, does it not? Okay. And then I have m to the 6th and n to the 9th. Okay. So, what is the cubed root of -27? It's -3. Why? So here we go. -27 is -3 times -3 times -3. All right? That is a group of -3s. And so a -3 is going to escape. All right? The cube root of -27 is -3. Odd roots can be positive or negative. Okay? So that they are allowed. All right, so the cube root of -27 is -3. The 6 is saying, I have m to the 6th. Imagine that all written out. How many of the m's get to escape? Yes. M squared gets to come out. And I have a bunch of n's all written out. How many get to escape? 3 of them. N cubed gets to escape. And what's left under my cube root? Just a 6. Okay? So again, imagine writing them all out, and you get a group of 3 is trying to escape. 1 gets to escape. All right, are you good with that? Yeah, I don't really want to do the 4th group. Let's look down to number 7 there. So radicals can add and subtract just like x's and y's. So if I have 5x plus 3x, we can add those together. 5x's plus 3x's is 8x's. Nice. So what if I had 5y plus 3x? Can we do anything with that? No. They have to match. They have to look the same. So I can't add these together because their radicals don't match. So we need to simplify first. All right. So I'm looking for square roots here. So 32 breaks apart into 16 times 2. And what is the square root of 16? 4. And what happens to the 4? It exits and multiplies with the negative 5. So we get negative 20 radical 2. Now, the other radical, I have to break it down. I have 7 radical 18. 18 is what times what? 9 times 2. And the square root of 9 is 3. So 3 pops out and we get 21. A plus sign is in between. And now it's 21 radical 2. Now you see the radicals match. So negative 20 radical 2's plus 21 radical 2's gives me 1 radical 2. All right, they are like radicals. So we can combine.
It's like a river or whatever. Like when we divide it in half. Like, you remember?
This is the Moses and the Red Sea.
It's like that.
Maybe. I mean, simplifying the radical, you're just trying to get it as small as possible and hope that they match. As long as those radicals match, we can combine their coefficients. Okay? All right, let's look here at number 9. These are cube roots. These are cube roots. So I need to be very careful here. 56. I'm looking for perfect cubes that go. Is it 8? I think it's 8. All right, it's probably 8. So I'm going to make that the negative 8 times 7. There's our negative 56, right? And what is the cube root of negative 8? Negative 2. Negative 2 times negative 2 times negative 2 would give me that negative 8. So a negative 2 is going to come outside that radical. So what does it morph into? What's it simplify? 6 cube root of 7. So the 7 is still under the radical. And then the cube root of 189. Again, I'm looking for perfect cubes. So my perfect cubes, let's see, 189. I have no idea. 189 divided by 27? Oh. Okay, 27 times 7. So that would be the cube root of 27 times 7. And again, what's the cube root of 27? Oh, yeah, I'm sorry. Thank you. What's the cube root of 27? 3. So a 3 escapes. And so we have the plus sign in between. 3 and the cube root of 7. 3 cube root of 7. So 6 cube roots of 7 plus 3 cube roots of 7 is 9 cube roots of 7. Did you guys do this in Algebra 1?
I don't know. Maybe. That was a long time ago. Algebra 1?
I would have done this in Algebra 1. Yeah. Let's look out here at number 10, one with X's in it. So now, what index are we looking at? 2, index of 2. So these are square roots, so we're using our perfect square numbers. Let's see. So we have the square root. 72 divides evenly by 9, yeah? Oh, 36. 36 is the largest, yeah. So that would be 36 times 2, x to the 5th. All right, what are my escapees here? A 6 escapes. The square root of 36 is 6. What else escapes? How many x's do we get to escape?
2.
2 of them. X squared comes out. Why? Why does x squared come out?
Because make it go like x 5 times, and then you have 2 pairs.
And that's right. If you expand those x's 5 times, you have 2 groups of 2. So an x from each of those groups gets to escape, and 1 is left behind. So what is our simplified radical here? 24
x squared.
X squared radical 2x. Very good. There's a 2 and an x left inside. All right. The other radical, we have a negative 3x. We're looking for the 242. 242 I don't know, 242 divides by 121. Oh, that makes sense. Yeah, all right. 121 times 2x cubed. All right, who are my escapees? Who gets to escape out there? 11 and an x gets to come out. And so that cleans up to be negative 33 x squared radical 2x. All right, 24x squared radical 2x minus 33x squared radical 2x is negative 9x squared radical 2x. Okay, so you can see all these parts that match. They are all the variables and radicals have to be identical in order to combine those coefficients. All right? Just make them, hopefully they match. And if they don't match, they just stay separated. They don't get to combine. Okay? Questions on those? You got that okay? Is this easier or harder than before? Easier. All right, let's multiply a couple of radicals. I think that multiplying can be difficult. Not actually, but it's pretty easy. This is a negative radical. You can think about it as a negative 1 times the square root of 18. How does this work? All of these things are being multiplied together. So this is really like a negative 1 times 2, which is negative 2 on the outside of the radical. And as long as our radicals have the same index, then we can multiply the numbers together under a single radical.
Oh, yeah.
All right? So as long as they match, as long as they have the same indexes. So 18 times 20 is 360. Hey, I should have known that. Radical 360. But then we need to simplify. So 360.
Yep.
That would be 36 times 10. And so what gets to escape?
6.
Yeah, a 6 gets to escape there. And they multiply. So what do we end up with? Negative 12 square root of 10. All right. On number 12, I have a 5 out in front. And this is a cube root of negative 12 times 36. I don't know. Negative 432. So I can multiply the, oh my God, is that called the radicand? I think it's called the radicand. The stuff under the radical, I think it's called the radicand. I can't remember. Okay, 432. I am looking for cube roots here, so perfect cube numbers. Let's see. 432 divides by what perfect cube? 216. Man, you guys are 216. All right. So that would be, let me think here. So this is like negative 216 times 2. That would give me negative 432. What is the cube root of negative 216? Negative 6? 1, 2, 3, 4, 5, 6. Yeah, okay. So that comes out as a negative 6, and they multiply together to give me negative 30 times the cube root of 2. Beautiful. Okay. Let's do 13. All right, I can multiply the outside. We get 21. And we have a square root. And on the inside, I would have 45. X to what power? X to the 4th, y to the 3rd. Very good. See, we had those exponents. All right. All right, we're looking for squares here. So the square root, let's see, 45 divides by 9 really nicely. 9 times 5 is 45. X to the 4th, y cubed. All right, what gets to escape?
The 3.
3, because the square root of 9 comes out as a 3. And what about the x's? How many x's escape?
2.
X squared gets to escape. And what about y's?
Y.
Y to the first gets to escape. And so I get 21 times negative 3 is... Oh, where did that's not a negative, it's just a times. I'm sorry. Yeah, 63. Sorry, that was just a times, not a negative. Better. X to the second, y, and then the square root of 5y. All right, questions on those? No, pretty good.
Whoa, do 14. That's a little bit.
So that's tomorrow. We'll talk about those tomorrow. Let's turn the page and we're going to look at dividing some radicals here. All right, so just like the numbers in front multiply together, the numbers under the radical multiply together, the same is true in division. So this, we're looking at 6 divided by 2, and then 6 and 480 are both under, gentlemen, they're both under a radical, so we can put it under a giant radical. 480 divided by 6 turns out nice. 480 divided by 6. I'm just going to write 480 divided by 6 and clean it up. So we can put them under one giant radical and simplify that. What is 6 divided by 2? 3. And then this 480 divided by 6 is simply the square root of 80. Now I do have to simplify the square root of 80. The square root of 80 is, let's see, that is 16 times 5.
4.
And so a 4 gets to escape. So 4 escapes, and we get 12 radical 5. All right, questions on that one? All right, so we did the same thing on number 18 here. We have like a 7 over 2 situation, and then both of these are under a cube root. So we'd have negative 32 over 4, which cleans up really kind of nice. So I have 7 over 2, and this is the cube root of, what is negative 32 divided by 4? Negative 8. All right. And what is the cube root of negative 8? Negative 2. Very good. So that comes out as a negative 2. And what is 7 halves times negative 2? Negative 14 halves, which is negative 7. Yep, you can think about that as 2 over 1. Those 2's would reduce, top and bottom. All right. Again, here we have 19. It's all under a giant cube root. What do you suppose we need to do? Simplify first. Absolutely. We can tighten that up. 288 over 2 is 144. J to the 7th over j squared. J to the 5th. K to the 4th over k. K cubed. All right. Now we're looking for our perfect cubes. Perfect cubes here. Let's see. I got to go back to my list. 144 on my perfect cubes list divides. 144 divides by. Well, it does divide by 12, but I'm looking for perfect cubes, not squares. So I'm looking at my perfect cube. Does it divide by 27? I don't know. No. 144 divided by 8. Oh, 8 times 18? 144 divided by 64? No. Okay, so 8 and 18.
You did 44.
Oh, it's still crazy? 144 divided by 64. Okay, all right. All right, so it looks like it's 8. Okay, so 144 is 8 times 18. All right, so what is the cube root of 8? 2 comes out. All right, j to what power escapes? just one j comes out, how many are left? 2 are left. Yeah, we're really just subtracting there. 5 minus 3. And just a k comes out, so that's totally gone. All right, and what's left inside? 18j squared. Good. So 2jk times the cube root of 18j squared. It is incorrect, ladies and gentlemen. If you leave off the cube root, if you leave off that index of 3, it is wrong, okay? That 3 tells us a lot, so it's really important that you don't lose it. Now, we also need to remember how to rationalize the denominator. We have a regular root number and we have a radical number, and those we can't clean up because they're not of the same type, okay? Here, these 6 and 2, totally regular numbers. We can clean those up. Radical 480 and radical 6, same kind of numbers, so those can tighten themselves up. Here we cannot. And 10 also does not simplify. So we cannot allow radicals in the denominator, so we need to rationalize. Do you remember how to rationalize? You have to multiply top and bottom by something.
By the square root.
By the square root of 10. Very good. I know, it's been a long time, right? We have to multiply top and bottom by radical 10. We're going to multiply straight across. That gives me 5 radical 10. 5 times radical 10. And then we have radical 10 times radical 10. What is that? Just 10. You can think about it as the square root of 100. But then, of course, the square root of 100 is just 10. Now, 5 and 10 are regular kinds of numbers, so they're a fraction. Can we clean them up? And so we have a radical 10 on top, and what on the bottom? A 2. If you're thinking of this as 5 divided by 5 is 1, and 10 divided by 5 is 2. So it reduces to a 1/2. So this is our simplified answer. 21. I see regular numbers here, 6 and 4. I can reduce those. 3 over 2. And so I'll clean that up in just a second. My radicals, I can simplify that one, but I'm not going to yet. I can't simplify radical 3, and I can't allow him in the denominator. So what can I do to get rid of the radical 3? Times top and bottom by radical 3. So that is 6 over 4 reduces to 3 over 2. And in my numerator, I have radical 24. And radical 3 times radical 3 is 3. All right. Hey, do you suppose my 3 on top and 3 on bottom are going to reduce? Yeah. All right. So I have the square root of 24 over 2. What do I have to do with the square root of 24? Do we have any squares in there?
4.
Yes. 4 times 6. The square root of 4 comes out as a 2. Oh, look at that. So we get 2 radical 6 over 2. What happens to the 2's? They reduce, and they just get radical 6 for an answer. Wow, lots of reducing there. That's kind of cool problem. All right, last one. Right here, I wrote it because I saw it in Delta Math. I want to say simplify first. And I should have done that here. I would have saved myself some steps here if I'd simplified that 8 first. Simplify the square root of 90. We know that 90 is 9 times 10. And so that's going to simplify as 5 over what? What gets to escape?
3.
3. Radical 10. Good. And now the 3 is fine. How do I get rid of the radical? Multiply by radical 10 on top and bottom. And so in my numerator, I get 5 radical 10 over 30. And then what can I reduce now?
5 and 30.
The 5 and the 30. 5 goes into 5 once, and 5 goes into 36 times. So radical 10 over 6 for that final answer. All right, you have any questions for me? Pretty good? All right, you got a Delta Math there? Oh, that was only 29 minutes. That's pretty good.